In this presentation, I'm going to go over an introduction to solar energy. Okay, so when you're done with this and after you do some exercises, you should be able to describe where solar energy comes from, define latitude and longitude, analyze the impact of latitude on solar conditions, find compass direction, define azimuth, solar elevation, attitude, solar window, and sun path, and finally to analyze a sun path chart for a given location. And this presentation is based largely on the videos in this week's lesson. All right, so let's start with the basics. Where does solar energy come from? Well, the quick and easy answer is it comes from the sun, but more specifically, it comes from nuclear fusion inside of the sun. So it's a little more complicated than just this. It's a multi-step process, but basically, when atoms fuse together, you go from hydrogen to helium in the core of the sun, and that releases energy when that happens. So nuclear fusion, which we've gone over in a previous lesson, um, is what generates the energy from the sun, okay? And so the sun then radiates the energy to the Earth, which is about 93 million miles away, depending on the time of year. Okay, and that's where it comes from. It's a giant nuclear reactor in space, and it just generates a heck of a lot of energy. If you remember, it's really hot on the inside, and then it gets a little actually cooler as you go outside, where the radiant energy is propagated. You actually don't need to know this. This is just an FYI, but this shows you the actual, the average solar irradiance, which is the power per unit area. You can see watts per meter squared. Remember, watts is power. And so the further you go away from the sun, okay, so we have our Mercury, Venus, Earth, Mars, etc. The further you go away, no surprise here, the average solar irradiance, or the average power of the sun, decreases. This number, incidentally, 1366.1 watts per meter squared, is called the solar constant and is the amount of energy, or excuse me, the amount of power that hits the Earth at any given time from the sun on the outer atmosphere. Okay, so let's answer these questions. About how much of the Earth's energy does the sun provide? So feel free to press pause for these questions, of course. As it turns out, the sun actually provides almost 100% of all energy on the Earth. If you recall from our previous lessons, you know that all our fossil fuels, coal, oil, natural gas, they are, if you recall, solar energy because they're made from dead plant material and in some cases animal material. But also, of course, solar energy. You'll learn in a future lesson that wind energy also is a result of solar energy. Even hydroelectricity is a result of solar energy. And some types of geothermal. Um, Basically anything but nuclear and deep deep geothermal. So like geothermal is based on magma deep within the Earth's crust and mantle. Everything else is solar based. Now that's just the energy that humans use, but don't forget that all of the there's a lot of energy being used by things other than people. Any plant and animal, they all survive off of solar energy, almost 100%. I mean, there's some minor, you know, geothermal, for example, it interacts with the biosphere a little bit. But plants and animals need solar energy. That's what we all live on. That's how we survive. That's how all living things survive. Okay, so here's an interesting question. I believe this was mentioned in one of the videos, but how much solar energy hits the Earth relative to the total energy used per year by humans? In other words, if you take up all the energy used by all the humans in a given year, how long does it take for the sun to actually provide that much energy on the Earth? And it's actually a nice, simple answer. It's actually every hour. So think about that. The amount of solar energy that comes from the sun, it takes exactly right around 1 hour. If we could fully capture a 100% of all the solar energy that hits the Earth in any given hour, we could actually power all human activity for an entire year. Now, there are a lot of reasons why this is not possible and not even desirable. I mean, we don't actually want to turn off the sun, so to speak. But that just gives you an idea of the magnitude of solar energy that's available. Okay, so let's get into some basic stuff here. So latitude and longitude. These are important, especially latitude. You probably you may know this from geography class or just if you have an interest in maps. But some important things to remember. So latitude. This is how far north and south of the equator you are. So here's your equator, right? So the equator um, is 0 degrees latitude, okay? So here's your 0 degree latitude, here's your lines of latitude, right? So they wrap around. So they go from east to west, but you're actually moving north. They indicate where you are north and south, okay? So here's your equator, 10 degrees north, 20 degrees north, 30 degrees north, so on. 10 degrees south, 20 degrees south, 30 degrees south, and so on, okay? So the equator is at 0 degrees. That's not terribly important for this class, but you should know that the tropics, okay? You've probably heard of the tropics. I'm sure you've heard of the Tropic of Cancer and or Capricorn. So they are lines of latitude, and they are at 23 degrees north and south. We won't get into the reasons why, but it has to do with the axial tilt. Okay, so that's latitude. They wrap around, all right? And it indicates where you are north and south. And if you remember from the video, they are all equidistant. So their lines of latitude are about 69 miles apart. Okay, so they're equally far apart from each other. Okay, now longitude is the other direction. So longitude indicates east and west, all right? So if you can imagine this giant circle around, going around the Earth from north to south, that's your lines of longitude, okay? And so they go, start at 0 at the prime meridian, which goes through Greenwich, England, which is up here. That's where there's a Royal Observatory there that has to do with history of, determining latitude and longitude. But anyway, so this is your line, your prime meridian, which is 0 degrees. Okay, this is 0 degrees. And then here you go, 10, 20, 30, 40, 50 west, 10, 20, 30, oh, east, sorry, 10, 20, 30, 40, 50, 60 west. Okay, so longitude indicates how far east and west you are from the prime meridian. Okay, now lines of longitude, if you look, you notice they actually meet at the geographic North Pole and the geographic South Pole. So what that means is as you go further north and south, they actually get closer together, all right? Whereas latitude, they're spaced equally apart. Longitude get closer and closer together until they actually come together at the North and South Poles. One way to remember this is the way I've always remembered it, is longitude. Lines of longitude are all very long, so they're all actually of equal length. Whereas lines of latitude, you can see they actually get shorter and shorter as you go to the North Pole. And by the way, if you recall from the video, it's not just like these are the only lines of latitude and these are the only lines of longitude. I mean, there are literally infinite lines of latitude and longitude, in between each of these, right? Okay, so as you go further north, your lines of latitude get shorter and shorter and shorter until you reach a point where they're basically one dot. Okay, so that's latitude and longitude. Just to give you an idea of the importance of latitude and longitude. Okay, so here you may have a little trouble orienting yourself, but this is where I am right now. I'm in Newark, Delaware. So here's the state of Delaware. Here's the state of Pennsylvania in the United States, New Jersey, New York, Connecticut, and so forth. Okay, so I'm at about 75 and a half degrees west, which is also sometimes indicated minus 75 and a half. And I'm at about 40 degrees north. Okay, so you can see here's the 40-degree north longitude line, and here's the 76 west. Okay, now this is a map of Colombia. Here you can see Panama, right? So you have the Pacific Ocean here and the Atlantic Ocean up here. Okay, now this is at 75 and a half degrees west. Notice it's the same, right? So we're at the same line of longitude, but the latitude line is very different. We're at about 9 degrees north, just above the equator, as opposed to the 40 degrees north. Okay, so I want you to look at think about where you are. Okay, we're right near the equator versus up in the middle latitudes. And think about what the different temperature differences would be. Okay, so huge difference in temperature, right? So the average temperature in Newark, Delaware is about 65 degrees Fahrenheit. That's not too bad. But you go down to Columbia and you're at about 83. So it's warm all year round. And then you look at the minimum temperature since 2010, and 8 degrees was our low, whereas 57, imagine that, the lowest temperature in Monterey, Colombia is almost 60 degrees, okay? So it's warm, right? Much warmer. So let's look at another comparison. We have Newark, Delaware versus Bordeaux, France. Both very exotic locations, of course. So anyway, you notice that this is about the same latitude, right? But the longitude, we're here almost at the prime meridian in Bordeaux, and we're 75 degrees west in Newark. So let's think about what the temperature differences might be there. Well, as it turns out, the temperature difference is actually pretty minimal, right? So the average temperature is almost exactly the same in both of these. The maximum temperature is very close to the same. Even the minimum temperature, it's not too far off actually. So what's the moral of the story here? What's the point? Latitude is very important. To a large extent, latitude indicates climate because if you recall, latitude is north and south, right? So I'm sure you know that the further north you go and the further south you go, like closer to the poles, the colder it gets. And the closer you get to the equator, the warmer it gets. Well, that's latitude, okay? So latitude is very important. It has to do with the amount of sunlight that you get um, and the angle of the sun. So the sun angle is also really important. Longitude, yeah, not too much. I mean, we don't care that much about longitude, to be honest, other than finding your location. In terms of solar resources, longitude really is not very important. So for solar considerations, latitude is extremely important. Longitude is not so important. Okay. Okay, compass direction. So I know this looks a little bit complicated, but um, at some point you're going to have to memorize all of these words that are very important in solar in the solar world. All right, so I'm just kidding. Actually, this is something to do with the the prevailing winds, or Aristotle named the winds sometime in ancient Greece. So anyway, that's not what we care about. A compass, right? I'm sure you are familiar with what a compass is. Maybe you have used one, maybe you haven't. Okay, but here's a compass. What does a compass do? It indicates your north and south. If you recall from the video, technically it's magnetic north and magnetic south. We're not going to worry about that distinction for now, but it indicates north and south, okay? So a compass gives you, I'm sure you're familiar with the directions, I hope, north, east, south, west, never eat sour watermelons, or however you remembered it. Okay, so, but you have the headings in between, northeast, southeast, southwest, northwest, northwest, etc. Well, these all correspond to degrees as well, all right? Now the degree, it's also on this compass, but here's just kind of a zoomed in view. Each compass heading also has a degree associated with it. This is also referred to as azimuth, which is really, really important in the world of solar, okay? So let's look at how it's normally noted or notated. So north is we'll use it in this class, and as almost everyone uses it this way. There are a few places that don't consider north as 0 degrees. So north is 0 or 360, okay? East is 90 degrees, south is 180, west is 270, right? So we have 90 degrees, 90 degrees, 90 degrees, 90 degrees. 4 times 90 is 360, okay? So we have 360 degrees all the way around, and east, south, north, west, all right? And then, of course, this is just the cardinal directions. You have all the points in between. Just 2 examples here. Southeast, due southeast is 135 degrees, okay? And then northwest is 315 degrees, okay? So you'll notice that this is 90 plus 45, right? So it's 90 degrees between east and south. Halfway between, you add 45 degrees, and that's your 135, and the same goes up here. Okay, so that's your compass direction. This is really important, an essential consideration in solar, and we'll use this in the following lessons. Okay, so if you recall from the video, there's something called a sun path. This is also very important. We need to know where the sun is. We're trying to get energy from the sun, so we need to have an idea of where it is at any given time. And as they went over in the video, if you recall, see if you can remember the 2 reasons that we have seasons, okay? And both of them have to do with sun angle. So first, the most intense sunlight is during the summer because of higher angle, and then the longer days occur in the summer. So in the summer, the reason it's hotter is because the sunlight is more intense and it's there for longer. And this will become a little clearer as we go through the rest of this presentation. And if you can kind of imagine it, I mean, you probably know this, but maybe you don't. In the summer, if you've ever noticed, the sun gets really high in the sky, so the sun angle is very high. It's more direct. Whereas in the winter, at least for those of us, kind of in the U.S., in most parts of the U.S., the sun angle can get pretty low. The further north you go, the lower the sun angle gets in the winter. So that just gives you a general idea of the intensity. If you recall from the video, this is actually the same amount of sunlight, okay? So this is the same amount of sunlight here and here. You notice in the summer, that same amount of sunlight's over a smaller area than it is in the winter. So you can just think of that sunlight being sort of spread out over a larger area. and that's one of the primary reasons why it's colder in the winter. But also, of course, the days are shorter, and there's a little bit, the sunlight is actually a little less intense also because as it travels through more atmosphere, it gets reflected, so you don't get quite as much. Okay? And this, I just wanted to remind you that, we get it in the habit, at least up here in the northern hemisphere, of saying, we have the summer solstice and the winter solstice. Well, you know, remember our summer is the winter in the south hemisphere and vice versa. So anyway, this trend is kind of reversed. So in December, the sun rays in the southern hemisphere are going to be like they look like in June, right? So in the southern hemisphere, it's the opposite. Okay, so that's sun path. Sun path is where it is, the path that the sun travels throughout the day. And you notice here, and this is kind of up where we are in the mid latitudes. In December, the sun never really gets very high in the sky, whereas in June it does. Okay, so that's sun path. Now your solar window is very closely related to sun path. If you recall from the video, the solar window is the area where the sun will be between 9 a.m. and 3 p.m. all year. So if you take your two sun paths, right? So this is the winter solstice, or the December solstice, excuse me. So this is the lowest point the sun will reach all year. This is the highest point that the sun will reach all year. Okay, so if you go from December to June, the sun path is going to gradually go up here, and that's indicated over here. Here's your equinox sun path. Okay, right in between the June and December solstice paths. Okay, so the sun will always be north of this line, so to speak, or above this line, and below this line. And so the solar window cradles is all of that, where the sun's going to be between 3 p.m. and 9 a.m. So if you're at this, location, the sun's going to rise in the east and set toward the west. So this is where the sun will be at 9 a.m. on December 21st. Here's where it will be at 3 p.m. on December 21st. Here's where it will be at 9 a.m. on June 21st and 3 p.m. on June 21st, right? So this solar window, this indicates the sun will always be somewhere within this area between 9 a.m. and 3 p.m. all year long. Okay, so this changes based on your location, primarily your latitude, but the solar window it indicates where the sun's going to be. At some point all year long, it's going to be in this space. Okay, so over here is your solar window for this. And so if you recall from the video, why do we do 9 a.m. to 3 p.m.? And that's because where the sun is most intense, right? So this is the hot part of the day. So it's the most important part for solar energy use. And ideally, you want to have very little to no shade during those times. And we'll kind of go over that in a future lesson. But solar window is really important. This is the, where you really, make your money. This is your bread and butter. Right here is the most intense sunlight throughout the year. Okay? Okay, so azimuth and elevation, or altitude. So remember, azimuth is just the compass direction. We know that. Now, elevation and altitude, this was also in your video. This is just the angle the sun makes between you and the horizon. So if you can imagine you're standing here at a house, right? The sun is up in the sky. You can imagine just pointing to the sun, okay? And the angle that is made between your arm and the ground, at least horizontal, assuming you're looking flat toward the horizon, that angle, that's your elevation or your altitude. Okay, so it's just an angle. And this will probably make a little more sense as we go through the last few slides here. And so let's go over a sun path chart. So a sun path chart indicates where the sun will be throughout the year, right? So this is a sun path chart of Wilmington, Delaware, okay? So you'll notice that this sun path chart also indicates your solar window, and really this just varies by latitude. Longitude really doesn't impact this at all. Okay, so let's analyze one of these charts. So this, as I said, is Wilmington, Delaware. Okay, this is my sun path chart. You notice the latitude and longitude here. Okay. All right. So I think the easiest way to think about what this chart is indicating, and it should be kind of clear from the solar window discussion, but we're kind of looking the other direction. So imagine you're facing south, right? So imagine you're physically standing like right here on the chart, and you're looking that way, away from the computer screen or your phone or whatever. Okay, that's south, right? So you're facing 180 degrees. And as you turn to your left, you're facing east. As you turn to your right, you're facing west. Okay? So now that you have yourself oriented, this chart tells you where the sun's going to be at any given time. So as they said in the video, these arcs are months of the year, or days, excuse me, of the year. So this is December, January, February, March, April, May, June, right? So the sun gets higher and higher in the sky as you go toward the summer. And remember, it works in reverse, so this is going to be July, August, September, October, November, back to December, okay? Here's time, so 6 a.m., 7 a.m., 8 a.m., 9 a.m., and so forth. And then we have our elevation and azimuth, okay? So let's just look at the elements. So where's east, west, north, and south on this chart? If you want to press pause, go ahead. So here's east, right? 90 degrees, if you remember from our compass. West is 270. South is 180. And the north is, 0 is not indicated here, but that's north as well as 360. So how do we know the azimuth and the elevation? Well, elevation is on the y-axis and the azimuth is on the x-axis. All right, so here's an interesting question. So think about this. Where are sunrise and sunset? So if you want to know when the sun's going to rise and when it's going to set at a given day, how do you know? Go ahead and press pause if you want. All right, so the sunrise is all here, right? So as soon as this line, this solar path peaks above the horizon, that means the sun is rising, okay? And the sunset, of course, is the opposite. So sunset's on this side. All right. All right, so let's do a little bit of analysis here. All right, so go ahead and look at these questions and feel free to try to figure out the answers, and then go ahead and press pause, and then I'll go over them in a second. Okay, so what date is the sun highest in the sky? And then what is the peak elevation that day? Well, the highest path is here, and that's on June 21st. You can probably read that. And the elevation is about 76.5 degrees. If you would follow this over, it's about 76. Well, actually 73.5 degrees, I believe. Sorry about that. So about 73.5 degrees. All right, so on what date does the sun rise exactly east and set exactly west, and what time are the sunrise and sunset in those days? Well, the equinox is when that happens. So here's our, if you notice, the sun rises exactly at 90 degrees east and sets at west, at 270 degrees west. So if you follow it, sun rises, it's noon, now it's setting, okay? So that's on March 20th, or the equinox, which should also be the autumnal equinox in September as well. And if you want to look at the time, so you just look here, it's right a little bit after 6 a.m. that it rises, and a little bit after 6 p.m. that it sets. And then finally, what elevation will the sun be at 4 p.m. on April 20th? So this is just one example. Where is it? And if you follow, so we have April 20th right here, and then look at our lines, our time. So there's 4 p.m. We follow this over. It's right around 30 degrees. Okay, so that's where the sun will be at 4 p.m. local time on April 20th. And the last, oh yeah, sorry, the solar window. So can you pick up the solar window here? So remember, it's 9 and 3 p.m. All right, so there's approximately the solar window. So the sun all year long is going to be between 9 a.m. and 3 p.m. is going to be somewhere in this window. I had to draw this by hand with, PowerPoint drawing tools, so sorry that it's not exact, but it should follow these lines exactly. And the last little thing, let's look at sun paths at different locations. So here's our Wilmington, Delaware, right? 75 west, 40 degrees north. So feel free to press pause and try to figure out where you think this is in general. So it turns out this is somewhere up in Greenland. This is the exact same longitude, but a very different latitude, 68 degrees north latitude. Okay, so as you can see, the sun takes a very different path by and large throughout the year at this latitude. It never really gets very high in the sky because it's so far north. And you notice, this is 68 degrees north. You notice in the middle of the summer, the sun actually never sets. There's no sunrise and no sunset. It's above the Arctic Circle. So you actually get a full 24 hours of sunlight for a couple of days. Pretty interesting, but the sun angle never gets very high, so you see it only gets about 45 degrees, even though it's there all day, whereas here we're, a shorter day, but about 70 plus degrees. Okay, here's one. See if you can figure out where this is. All right, so this is Miami, Florida. It's 80 degrees west, about the same longitude, but we're almost at the Tropic of Cancer here. And so you notice we have a very almost 90 degrees almost directly overhead for a very long period of time on our solstice, and the days are also much longer. And the last one here, This is kind of a trick question. It looks very similar to this one. I'll give you a clue. Notice this says 0 degrees. Okay, so our peak is at 0. So what does that mean? That means we're actually in the southern hemisphere. All right, so we're at, whoops, that's, excuse me, 40 degrees south. I apologize for that. So that's 40 degrees south. We're actually in the southern hemisphere. So the highest point in the sky is actually facing north, right? So you would have to see the sun's peak, you would have to face north. Okay? All right, well, that's it for this presentation.